Okay, welcome back. We're in part 6, the final section on analytical geometry, and we're enjoying some tangents in our second example. Let's dive straight in. Determine the equation of the tangent to the circle, blah, 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 at that point. Now, of course, I've encouraged you, just a little sketch can be useful. So we've got this circle. I don't even know where the center is or how big the radius is. 1 minus 1 clearly is a point on the circle, but yeah. So we've done enough of these, hopefully, in the previous part 5, where you turn this into center radius form. So you went, okay, well, that's x minus 3 all squared minus 9 plus y plus 5 all squared minus 25 plus 14 equals 0. Okay, hopefully we did a few of those and then went, no, but in center radius form, we went plus y plus 5 squared minus 9 minus 20. Maybe I should do this. Minus 25 plus 14 minus 11 minus 9 minus 20. So equals 20. So our center is at 3 minus 5. Remember, it's like minus 5. And our radius is root 20. So if our center here is at 3 minus 5, somewhere like there, and maybe I can just make a note of what it is, 3 minus 5. Now, our sketch doesn't have to be perfectly to scale, but I don't want to just go, well, I don't know, there's my circle, okay, close enough. And then 1 minus 1, well, things aren't really matching up so nicely now. So let's just have a look here. Square root of 20. Well, the square root of 16 is 4, right? And the square root of 25 is 5. So the square root of 20 is somewhere between 4 and 5. Quite a bit closer to 5, I would say. No, is it 4, 7? Let's just do another way of checking that to go, well, the square root of 20 is 4,47. Actually, 20 is closer to 16. So if we think of that then, that the radius is less than 5, this distance here is 5. So therefore, if we were to draw a circle, it's not going to cut the x-axis. But the radius is bigger than that distance. There's 3, so it is going to cut the y-axis. So even if you draw an egg like I just drew there, doesn't have to be this nice perfect circle, but regardless of scale, it shouldn't cut the x-axis because the circle doesn't. Okay, so with all of that, it's touching at the point 1 minus 1. Well, that's going to be here somewhere. Don't know. I mean, there's 3, so probably there. Now my scale's sort of good enough. But it's enough to tell us, okay, now we know what to do. We've got a radius over here that's at 90 degrees. We know the coordinates of this point, so I probably should have put it in. 1 minus 1. I don't really see that one. Let's do minus 1. It's getting worse. Okay, so there's our circle. And as I said, because I do think it's such an important point, it's a rough sketch. It's not necessarily to scale. So we must bear in mind which bits are we trusting from the diagram, which aren't we. I'm trusting that at this point it's going to have a positive gradient. Even if my circle isn't great, it looks like it's a positive gradient. This radius has a negative gradient. I can trust that. I can trust it doesn't have x-intercepts. But I can't trust that that gradient looks like it's about 1. No, that's not good enough for me. I haven't got that scale right. Okay, so let's work out some things. This looks like the first example now. So we can work out the gradient of the radius is rise over run is how we always work this. So I'm just scribbling that and going, well, from 1 to 3 is 2, and from minus 1 to minus 5 is minus 4, I think, which is minus 2. I'm trusting that my sketch says this is negative. It does seem to match. And then if we work out the gradient of the tangent, well, it's just the negative reciprocal. Okay, so from there, what we can work out is, well, I think for this one, if that's 1, going left by 1 means we must be going down by a half. So I can go straight to my equation. Y equals a half x plus c. But I know that if that's minus 1, then this must be minus 1.5 or minus 3 over 2. didn't quite get that, maybe you're more comfortable and happier if you just said, you know what I would rather do is I'd say I'm going to substitute that point in 1 plus c, let me move out the way, and therefore work out that c is indeed minus 1.5 with your substitution. Okay, that's our second example. I'll see you for the third one in the next video.